with it being online. Has that been good? Or
Yeah, I kind of prefer my classes to be online now because I'm getting so used to it.
you say you kind of prefer, say it again?
So I kind of prefer my class to be online now anyway because I'm getting used to it.
Yeah, since you're used to it. And also, I think the big nice thing about it being online is, look, you don't have to rush down to UDC. You could be, I don't know if you're a teacher aide or anything like that, but it's hard to get there sometimes,
Mm-hmm.
Okay, so basically here's your problem that you have for problem 15. The only thing I did is I took care of the division, which means I got to flip this thing, flip the second fraction. So I put the 7x cubed minus 7x squared on the top and the 6x squared plus 9x plus 3 on the bottom. And I know you got it right, but I'll go ahead and go through it. But the restrictions, it's not a big deal. I'll show you what you do there. So I'm factoring everything. So I factor a 6 out of that, and that'll give me 2x plus 1. And on the bottom, couple things on that bottom thing. First of all, you can factor out a 21. I'll do this off the side down here. So if you factor out the 21, you're left with x squared, and 21 divided by 21, when you factor that out, gives you a minus 1 right there. Well, that factors farther. So the x squared minus 1 actually factors into x plus 1 and x minus 1. I don't know if you got that, but okay. So you must be pretty good at factoring and stuff. Do you remember that from high school, or did you just pick it up here?
Oh, I remember a little bit, but not a lot.
Well, no, that's good because there's a lot of factoring in these things. And I think these are the hardest problems. I mean, most algebra intensive problems anyway on the whole praxis thing. And chances are, if you get one of these, it'll be like one of them, it won't be like a ton of them. And they do take a while to do. There's other problems that you can get done faster. So if I got this one on the praxis, I'd probably skip it and go back to it later. Yeah. So the common factor on this thing is a 7x squared. And then on the first term, the only thing extra is an x. And on the second thing, there's nothing extra. So when you take 7x squared divided by 7x squared, it's just 1. And that doesn't break down any farther. On the bottom, that's a tough one to factor too. You try factors of 6x squared. And I would just, right off the bat, I would try 3x and 2x, because 3 times 2 is 6, and x times x is x squared. There is a chance it could have been 6x and 1x, but I would try this to start off with. Now we need factors of 3 that add up to 9 when I substitute it in. And the factors of 3 I'm going to do is 3 and 1. Yeah, and you know what I should have done? I should have factored out the 3. So I'll do that right now, but I'll show you that this works. So if I check my inner and outer here, that's 6x right here, that's 3x, and 6x and 3x is 9x. The only other thing I can do, and it's worth it for me to do this, is right here, just in this one, I got a common factor of 3. So I don't have to write all this down again. I'm just going to put the 3 in front and say, well, okay, I'm factoring that out. And when I factor out the 3, that's going to make this just an x plus 1, because when I multiply the 3 back through, I would have the 3x plus 3. And the reason why that's important to do is because now I can see that this 3 will divide into this 6 2 times, so that will reduce. And then the 7 goes into 21 3 times. And then looking for other things that cancel out, there's not a lot. So I have a x minus 1 that cancels out, and the 2x plus 1 cancels out. So like you have up there, the only thing left is a 2x squared, which you have right there, and a 3x plus 1 squared. So that's all right. Now the restrictions are what makes any denominator equal to 0. Well, this denominator here broke down into this stuff, and you don't have to worry about some sort of constant because there's no x with it. So the only bits that you have to worry about are the bits here that have an x with it. So we say to ourselves, what makes x plus 1 equal to 0? Well, that would be -1, because -1 plus 1 is 0. What makes x minus 1 equal to 0? Well, add 1 and you get x equals, well, right here I have to, sorry, this would be -1 right here, because -1 plus 1 is 0. So that would be a -1. So that's one of them. Right here, what minus 1 is equal to 0? You could solve it. You could add 1 to both sides to get x equals 1, but that's it. X equals 1. 1 minus 1 is 0. Looking at this denominator, there's 2 pieces here. This is the same thing. This denominator, x plus 1 equals 0. So you don't get anything new with that. It's the same thing as this one. But this one, the 2x plus 1, you get something from that. 2x plus 1 equal to 0. Well, if you solve that, we would subtract 1 from both sides. And if I subtract 1 from both sides, I get 2x equals -1, and then divide through by 2, and I get x equals -1/2. So far, I got 3 values that will make the denominator 0. And if you have a denominator equal to 0, division by 0 is undefined. That's why it's a restriction on it, because it makes the denominator 0, which makes the whole expression undefined. But the other thing that you need to watch out for is the original problem over here had that 7x cubed minus 7x squared. So you also have to watch out for anything that would have made that 7x cubed minus 7x squared equal to 0. Well, that broke into this stuff up here. It broke into 7x squared times x minus 1. Well, the x minus 1 gives us x equals 1 in terms of when you set it equal to 0. And the 7, which is not new, we already have that one. But the 7x squared, when you set that equal to 0 and solve it, the only thing that you can take any number of times to get 0 is 0. So the only value that will work here is 0. If you take 0 and squared, you get 0, and 7 times 0 is 0. So that's another one of the restrictions. So the total amount of restrictions are 0, -1, 1, and -1/2. So you had the -1 and 1, but that's the only ones you missed there. You okay with that one?
Yeah.
Okay, so I'll go ahead and do this one. So 18. That was, so here, I'll mark that down. That was number 15. So that was
So
number.
on that one,
Mhm.
I seen the answer. I think the answer was like 1/5 or something like that.
This one here?
But yeah, but I don't know how it would have been 1/5. I'm confused.
Well, the reason is because this value right here isn't at 1. See, this goes 20, 40, 60. So if that's 20, 40, 60, then this number right here must be 10. So the 2 points that it goes through on 18 is, one is that point right there at 10, 0, and the other point that goes through is 0, 2. So it's the scale of the graph that gets you. So that's 10. See, 10, 20, 30, 40, that sort of thing. So that's 10. That's 10, 0. That's 0, 2. And at that point, you can get the slope. So actually, you could get the, well, we know the y-intercept on this y equals mx plus b. You can get the b very quick by just looking at it. The y-intercept is 2. So that's your y-intercept. So you don't have to do anything special. There it is. That's your y-intercept. And the slope we could count. You could use the slope formula, but we could count and say to go from here at this point 0, 2 down to this, which is really 10 to the right, you had to go down 2 and to the right 10. So going down is negative. So see, going from left to right, if you see that line is going downhill, it means it has a negative slope. Yep. So it'd be -2 for going down 2 and then run 10, because that's a 10 right there. And then that reduces down to 1/5, -1/5. So the equation would be y, there it is, -1/5 x plus 2. Cha-ching. Yep. Okay, let's see what other ones we got there. So this one's a real quickie, and I did see a problem like that on the praxis. And you know, there's a lot of praxis.
I got that. I think I got that one correct, but I didn't put the
parentheses. That's all you need. Yeah, that's it. Oh, yeah, it's -1. So not 1, 3.
But when you click the show all tries, I tried to
-1,
do
3.
like negative, positive. Yeah, so I just kept clicking it, but I didn't figure out until afterwards around the parentheses.
That's it. So you got to have parentheses around. So that's all you missed on that. Okay, so let's see what else we got. And then this one. So let's go down here to 28. So with 28, we know it's a parabola. They even say it's squared. So the first thing I look at here, the easy thing to get is the k. That k value at the end is how much it's been shifted up or down. So you see the typical place for this to be is right here. So how much has this been shifted up from here? 3. So the k is 3. That's all there is to that. And then the h is how much it's been shifted right or left. And it's been shifted to the right 2. So the H is 2. Now, I always say to take the opposite of that, but they already did. See, they have a minus sign right there already. So really your equation would be y, well, let me get this much. I don't know about the a yet, but it would be some value times this quantity x minus 2 squared plus 3. So now in terms of that a, what you do there is see how it's basically looking at the next point that it hits right on the money, like right on the crosshairs. So if you look at this vertex point right here, the next one it does is right here. And so what you can do here is say, well, that's what? Up to run 1. So that's why the A is 2. Do you follow that?
Yeah.
And that should be the equation for this.
Okay.
And I'll even check it here. Yep. 2 times x minus 2 squared plus 3. Yep. All right. Yeah, was there anything?
That's it, right? Oh wait,
just one little thing here. So let's take a look at this one. This is number, I think it's 29. So on 29, okay, let me write this one out. We want F inverse of 4. Well, when you're doing inverse functions, you're going from the right side of the table to the left side of the table. The typical way is to go from the left side to the right side. So what we do first of all is find 4 on the right hand side. Boom, there it is. And we find the value on the left, which is 6. So now that took care of all this stuff is just 6. So now we need to get F inverse of 6. So we do the same thing again. We look for 6 on the right hand side, which is right here, and the value on the left is 5. So it actually should be 5, and we can check it here real quick. Yep, that's it. So when you do these, and they don't seem too bad. The thing is that have you taken the praxis yet?
No, I was going to do it. You talking about the one that's on a grade book right now?
Oh no, no, not the praxis for this course, but the actual praxis that you have to pass to get.
No.
Do you have it lined up to take it anytime soon?
No, I keep forgetting the website to go to.
Oh, okay. Well, you can probably just Google it and get the praxis test. But what I'm saying is, see, you're not going to have access to this site, after the semester is over. So you might want to, if you got a printer, I would probably recommend printing out the, some of these tests that you took and that sort of thing, so that you can use them to study for the praxis test. And then I even have a link on this site. Here, I'll do it here a second, for a booklet that you can use, or you might be able to find the booklet online yourself if you really want. But let me see if I can find it. Well, I don't know where it is off the bat. I used to have that on here. I probably still do. Final homework assignment. I don't know. So I'm not sure where that, but anyway, your tests are good for the, yeah, I don't see my praxis. You can probably find it online too, but I just can't find it right now. Yeah. Okay. So I'll see if anybody else has any questions. Anybody else there, Jessica or Chanel, have any questions at all?
Thank you, Professor. I'm gonna head out now.
Okay. Hey, you know what? It might be. Let me just see if it's here. Textbook links, video. There it is. Praxis test. So it's here. I'll go back to it. So where I am is under this algebra area where it says instructional materials. If you do textbook links, then you'll see it's a whole book, and it tells you what pages that you should go to and stuff like that. So when you take it, I wouldn't wait too long to take it, because you're pretty good at this math stuff, and it's going to go. What happens is if you don't do it, you go downhill. You know what I mean? So you might want to sign up for it and take it soon and just review this stuff. Okay. Well, anyway, if you're going to take off, I'll talk to you later. No problem. Bye-bye.
Bye.
Okay. Any other questions from anybody else? Hello.
No, I don't think I have any questions.
Okay, so you guys have the dates for everything at the top of the thing. So if you don't have any other questions, really, it's just getting the assignments done is all that's left. So, that's all we're doing now is just any reviews, questions that you have. Okay.
Okay, will you have class next week? Will you be on Zoom next week?
I'll be on too, but it's just going to be, come with your questions. Okay.
Right. Okay.
Okay. Sounds good.
All right. Thank you.
Thank you. Okay.
Okay.
Bye-bye.